Welcome to lecture 13 in risk management and insurance. In this lecture, we build on the two figures that we discussed in the previous two lectures. Remember this figure we had in lecture 11. It showed that the risk-averse person avoids a fair game. Even if the game is fair, the risk-averse person will avoid it. Now, we expanded on this figure in lecture 12 to show the so-called certainty equivalent. Now, in the current lecture, I will build on this figure and apply it then directly to insurance. Now, in insurance, it is natural to consider random shocks to wells with a negative expected value. Such shocks you call perils. So let's look at the binary random variable. So either you have a loss, minus x, so the random variable may take a value minus x, or maybe it takes a value 0, no loss. So it's a binary random variable, no loss or loss. A loss may occur, let's say, with a probability pi of 2%, and no loss with maybe 98%. So we move away now from the fair games that we discussed in earlier lecture, where you have 50% chance of winning, 50% chance of losing, and the expected loss then is 0. Here, obviously, the expected loss will not be 0, the expected loss will be negative because you have either no loss or you have a loss. And there is no way actually to have a gain here. Now let's calculate the expected value of this binary random variable. Okay, expectations you calculate, you take some outcome, you multiply with its probability, then again you take the outcome and you multiply with probability. Now we have only two outcomes here, two possible outcomes. Either we have a loss, maybe with a probability of 2%, or we have no loss, maybe with a probability of 98%. So the expected loss of the game is actually just the first part here, because here I have a 0. Now, you also know how to calculate variances. In a variance, you take the possible outcome, you subtract the expected value, you square, and you multiply with the probability. And then again, you take the other possible outcome, you subtract the expected value, you square, and you multiply with the probability. Now, this will give you the variance. Now, here's the expected value we just take from above. The expected value is x pi, okay, minus x pi. So I plug this in here. So we have here the outcome or loss. I look at the gap between the outcome and the expected value. I square it, and the loss, okay, may occur with a probability of 2%. So I multiply here with the probability. No loss, subtract the expected value of this outcome, square it, and multiply again with the probability, which may be here 98%. Now, when you multiply this out, okay, you will get that. So we deal here with a binary random variable. We have either a loss, maybe of 2%, or no loss, maybe of 98%. So we have moved away from the old problems that we looked at with a game, with a fair game, where you have very easy gain or lose, and the expected value is 0. Now here, the expected value actually of this binary random variable is negative. Now let's look at the expected wealth of a consumer without insurance. Okay, that's just the initial wealth plus the expected loss. The expected loss you take from up here, that's this negative figure. So you have the initial wells, you subtract the expected loss. So that gives you the expected wells if the person does not buy insurance. Now, then let's look at the expected utility without insurance. So we have here initial wells, you subtract the loss, and out of this you take the utility. So the U is actually again a functional operator. It's not the multiplication here. That stands for a function. I use U because that's utility function. Okay, math classes you tend more to use a small f. That's a functional operator. So you have your wealth. You have the wealth 0, W0. You subtract the loss, that's the utility of it, and you multiply with the probability. And then you do it also here for a situation with no loss. Your initial utility just stays constant. Your initial wealth just stays constant. Okay, you take the utility, you multiply with the probability, maybe 98%. So that gives you the expected utility if the person does not buy insurance. Now, a risk-averse consumer is willing to pay more than the fair insurance premium. So that's okay, how we define a risk-averse person. The fair insurance premium is defined as the expected loss in absolute terms. So if the expected loss is 100, then naturally the insurance company must charge at least 100, else it gets broke, because the insurance company naturally must cover the expected loss. But then on top of it, naturally we'll also have administration costs. So actually the true insurance premiums will be more than the fair one. But the consumer who is risk averse actually will be willing to pay more than the fair insurance premium. Now we call this the actuarially fair insurance premium. That's because it's in the actuarial science, okay, where they discuss insurance. Some universities actually have departments of actuarial science, and in those departments you have a lot of statisticians and mathematicians. And for example, the University of Cape Town has a department of actuarial science, and that's where insurance is discussed. So we speak about the actuarially fair insurance premium, but you can also just call it a fair insurance premium. And the fair insurance premium is just the expected loss in absolute value. Now, the consumer's risk premium row. This corresponds to the row that we had in the last lecture. This risk premium is defined as the extra payment beyond the fair premium. The fair premium is expected loss that makes the consumer indifferent between buying and not buying insurance. Now, equation 18 defines the risk premium of the consumer in this context here. We had this risk premium already in the previous lecture, and we also called it a row. So let's have here on the right side of equation 18, let's have the expected utility. Now the expected utility you can actually take from equation 16. Here we have looked how you calculate the expected utility. It's just a utility when there is a loss times probability, and utility when there is no loss times probability. That gives you the expected utility. You can plug this in here, but actually we do not really need it, okay, so I don't do it. On the left side, you have the expected utility with insurance. Now, if you buy insurance, your wealth will be reduced by the insurance premium. You surely have to pay the fair premium, which is the expected loss. else the insurance company does not survive. On top, a risk-averse consumer actually will be willing to pay more than the fair premium. So actually, okay, we also have we will subtract this row here. And the question is actually, what is the maximum row? So this left side of the equation, the expected utility with insurance, is equal to the expected utility without insurance. So we can use this equation to solve it for a row. And then, okay, now this here is naturally just again the certainty equivalent. In last lecture, the certainty equivalent was just W0 minus rho. Now here it's W0 minus expected loss minus rho, because we have actually the expected loss is negative here. So the consumer, okay, has initial wealth W0, okay, then this wealth is reduced by the expected loss, which is equal to the fair insurance premium, and so the consumer actually is willing to pay even more, okay, because the consumer is risk averse. And this then actually gives us the expected utility with insurance. And with a sufficiently big row, this left side here will become equal to the right side. Then we have indifference. So the question is, what is the maximum amount? Okay, that really the consumer is willing to pay, okay, for insurance. So we solve this equation again for rho. You apply the inverse function again. You can do it because the utility function is strictly increasing. So you will have the inverse function here, u to the -1, u to the -1 of EU, and then actually you rearrange this. Okay, okay, you solve it for a row. It's just rearranging, and so you get actually this expression here for a row. So this equation here defines the risk premium. I have not yet explained this equality sign here. Now that just comes from the earlier equation. You see, we can collect those two terms here. They're actually expected wealth. Initial wealth minus expected loss gives you the expected wealth. We have this here. Initial wealth minus expected loss gives me expected wealth. So it comes from equation 15. So that's coming from equation 15 here. Okay, we can now illustrate this again with this graph. That is now the third time that we look at this graph. So we have here the wealth, initial wealth. Here we have the wealth minus the loss, possible loss. So it's either we are here, maybe with 98% chance we are fine, there is no loss, so now utility will be quite high. Okay, or maybe we are unlucky, we have the loss, maybe with 2% chance, okay, so then we are here. The expected loss you can calculate using equation 16. So you go back to equation 16, calculate expected loss. It's naturally now closer, it's now not in the middle because the chance of this is 98% and so this is only 2%. So the expected loss will be farther up. It's not exactly in between, okay? So this you expect utility and that expect utility up here. Now, we have the initial wealth here. You have the expected loss. This gives me the expected wealth. This expected loss is actually just the fair premium. Now, it would be very nice if this expected wealth, okay, if we really could have this certainty, then actually we would be here at point A. So if we would get insurance at just paying the expected loss, just paying the fair premium, and then this becomes certain, that would be nice. Then we have actually this utility up here. Now, it's much better than buying no insurance. Remember, that's the expected utility of no insurance. But because we have here this concavity of the utility function, actually, the consumer will be willing, a risk-averse consumer is willing to pay more, okay, than just this fair premium here. Question is how much more? Now, if you, maybe the consumer pays so much more here than just a fair premium, so the wealth actually declines. Now, if this becomes some really certain wealth, because if he gets insurance so cheap, yeah, okay, then again, that would be very good. Okay, then utilities up here, and not buying insurance, it's down here. So, so risk-averse consumer, that's a maximum amount that a risk-averse consumer would pay, okay, for beyond the fair premium. Pays the fair premium, wealth declines, then also pays this row here, that's a maximum amount, and then actually getting insurance or not getting insurance, it just amounts to the same. The person is indifferent. So that's again the certainty equivalent down here. This point C is shown by this equation 18 here. You solve this equation 18 for a row, and then you have the equality here between expected utility without insurance and expected utility with insurance, if this row here is big enough. So your wealth falls because we have the fair insurance premium here, that's expected loss. On top of it, the person is willing to pay more because of the curvature here. The person is willing to pay more because the person is risk averse, and that's a maximum amount, and actually the maximum amount that the person is willing to pay for insurance. Then actually this insurance, that's a certain wealth here, that's a certainty equivalent. So utility will be here on the solid line, and this utility here then is actually also equal to the utility of not paying insurance. Now, if insurance would be more expensive, okay, or down here, then you have certain wealth. Yeah, okay, your expected utility would be here. So it would be better actually not to buy insurance. Okay, so you really have to relate this graph here, you have to relate it to this equation. This equation defines the row. This equation defines the row. And the maximum willingness to pay for insurance is actually the fair premium under this row here. Okay, that may be something you have to think a little bit about it. It's not high-powered math, but just to understand the problem here actually is important. Now, so we have seen the maximum willingness to pay for insurance is the sum of the expected loss plus the risk premium. Okay, the expected loss in absolute term is just x times pi. We have seen that before. So the maximum willingness to pay is just EX plus rho EX in absolute terms. That's what we have in equation 20. Now, let's move from the risk premium to the insurance premium. And it's important that you do not confuse the risk premium with the insurance premium. The insurance premium is actually the price the insurance company charges to the consumer for the insurance coverage. So the risk premium is on the side of the consumer, the insurance premium is really what the insurance company charges then in the end, and that depends on the behavior of the insurance company. We will discuss this actually in a separate chapter, okay, when we discuss the behavior of the insurance company. Now we can say in the long run, the expected loss flows back to the consumer as insurance payouts. If you wait long enough, then naturally you get the expectation of the loss, okay? Because the losses will arise and the insured person will be compensated. So the true price of insurance equals actually the excess of the insurance premium over the expected loss. So in the longer term, expected losses will materialize and people get compensated, so they get that money back. But what they pay on top of this fair premium here, of this expected loss, that they don't get back. So that's the true price, actually, of insurance. Now, from the point of view of the insurance company, the insurance premium, as you use a symbol capital letter P, must be bigger than the expected loss in absolute terms, else the insurance company gets broke. If the expected loss is 100, the insurance company surely must have 100, else it cannot cover you in the long term. And the insurance premiums that the insurance company charges must be less than the maximum willingness to pay. Yeah, okay, so the insurance premium will lie between those two boundaries, between the fair premium, the expected loss, and between the amount, okay, the maximum amount that people want to pay. And we will discuss this and actually further, okay, in a separate chapter. Now, the price of insurance, we usually take, or we sometimes take this ratio here as an indicator of the price of insurance. The premium income divided by the insurance payouts. You see, the insurance payouts flow back to the consumers. Now, if the consumers get 100, okay, insurance payouts, and the premium in that year was 120, yeah, okay, they got back the 100, so there is a price for the insurance was 20. Now, this argument then really assumes that the payouts are close to the expected value. That those insurance payouts or indemnities, sometimes they are called indemnities, that those insurance payouts are actually close to the expected value. Now, if that's true, okay, that's expected value, so that would be actually a fair premium in that case. And then now, if the premium income of the insurance company is bigger, okay, then you pay a positive price, okay, to get the insurance. Because this fair premium will flow back to the consumer. But you have to be careful here with this argument. You see, annual insurance payouts can be quite volatile. For example, with earthquake insurance, maybe you don't have an earthquake. And so the insurance payout in a certain year is 0. And you still pay a premium. So in that case, then for this argument, you have to look at the long-term figures. Okay, this finishes this lecture. So repeat this equation 18 here, that's crucial to understand, and check how it relates actually to this figure here. We define in this figure the row. In equation 18, we've defined the row, the consumer's risk premium. And the consumer's risk premium, then actually don't confuse it actually then with the insurance premium that the insurance company charges. That's something completely different. And we also have seen the boundaries here. This insurance premium should surely be more than the fair premium. okay, because that money as a fair premium in the long term, that's expected loss, and that flows back to the consumer. Okay, so the insurance company must cover that. But the insurance premium naturally cannot exceed the maximum willingness to pay for insurance. And in this maximum willingness to pay, actually a row appears. So you see, in the maximum willingness to pay, that's expected loss plus the row, the risk premium. The maximum willingness to pay is expected loss plus the risk premium. Okay, that is surely something that gives you a little bit work. Now, okay, thank you.